Hello friends, myself R.D. Mahajan, Assistant Professor, MIT Aurangabad, presenting second part of the video for unit step function and displaced unit step function. In the previous part, I have discussed first two cases for multiplication. In this, I will discuss the third case, multiplication by f of t minus a. This function is called as f of t minus a to displaced unit step function u of t minus a. Therefore, this figure represents the unit step function displaced one. It is displaced by a distance a, and for that we have to multiply by f of t minus a. Okay, f of t minus a means whatever f of t we have considered, each point is displaced by a distance a towards right, and therefore the figure is shifted, each point is shifted towards right by distance a. Therefore this becomes point a dash, this becomes point b dash, c dash, d dash, and like this. This represents the displaced function f of t minus a. And therefore if you try to find the multiplication of these two, function f of t minus a multiplied by u of t minus a, and to obtain the value we take the help of basic definition of this. It is having two values, 0 and 1. Therefore when it is 0, this becomes 0 for the condition t less than a, and another value for that function is 1. Therefore 1 into this f of t minus a, we get f of t minus a for t greater than or equals to a. Okay, means using either figure or the definition we get these two values, and the same we can represent in terms of the figure, resultant figure. Therefore the portion towards left of a becomes 0. Therefore whatever the portion towards left of a means between a dash to b dash, that becomes 0 or vanishes. Therefore I will remove this part, and the part of the curve from b dash to d dash, that represent the product of f of t minus a into u of t minus a. Okay, therefore this is the geometrical representation of this product f of t minus a into u of t minus a. And after knowing the value or knowing the figure, we try to find out the Laplace of it, and therefore Laplace transform of f of t minus a into u of t minus a. Okay, it is equals to integral from 0 to infinity e raised to minus st into this function. That function is f of t minus a into u of t minus a, and its integration with respect to t. We split this integral as 0 to n a onwards, and therefore it is equals to integral from 0 to a e raised to minus st, and for that range its value is 0. That function value is 0, therefore into 0, and then a to infinity, its value is f of t minus a, therefore e raised to minus st into f of t minus a. Okay, and therefore this part becomes 0. Therefore we have integral from a to infinity e raised to minus st into f of t minus a dt. We call this as equation 1. And to obtain the value, we put t minus a is equals to some x. Differentiating this, we get dt is equals to dx. And the value of t, it implies the value of t as x plus a. Substituting this here in this, we get, we try to get the new limits. When t is a, we get x is equals to a minus a, we get 0. When t is infinity, we get x as, when t is infinity, we get x as infinity. Therefore the new limits are from 0 to infinity. When the value of t is a, we get x as 0, and when t as infinity, we get x as infinity. Therefore if we substitute that as a new limit here, it is from 0 to infinity. E raised to minus st, the value of t is x plus a into f of t minus a, but t minus a is x, and dt is dx. Okay, we have to integrate it with respect to x, and therefore with respect to s is constant term. Therefore we can split this as e raised to minus as a constant term. I can take outside the integral sign. Integral from 0 to infinity, the remaining is e raised to minus sx into fx into dx. Okay, and therefore it is equals to, this is exactly similar to your basic definition of Laplace transform, where limits are 0 to infinity, e raised to minus st f of t dt, means that x we can replace by variable t, and that is nothing but e raised to minus as. This is the Laplace of that function fx, and therefore it is equals to e raised to minus as, and Laplace of any function we denote by f bar of s, and therefore we have Laplace of f of t minus a into u of t minus a as e raised to minus as into f bar of s. Therefore we get this one. This is a standard result. Okay. To find Laplace of f of t into u of t minus a, to find Laplace of f of t into u of t minus a, first express f of t as a function of t minus e, as a function of t minus a, that is f of t as function of t minus a, by rewriting it by adding a and subtracting a, we get this, and therefore Laplace of f of t into u of t minus a is nothing but Laplace transform of f of t we are writing as phi of t minus a into u of t minus e, and as per the last result, f of t minus a into u of t minus a is e raised to minus as into Laplace of this function, and Laplace of that function is phi bar of s. Okay, therefore this is the note whenever we require to find Laplace of this type of product, any continuous function f of t multiplied by a displaced unit step function u of t minus e. Then last case, fourth case. Case fourth, part of function f of t between points a and b. Therefore, if I want to find the portion between this point a b, how we can obtain it? For that, we have to multiply this function f of t by displaced unit step function u of t minus a, and second time multiply the same function by u of t minus b, and then take a subtraction of these two to get the value. Therefore, that part I will explain. Therefore, this is the continuous function f of t multiplied by u of t minus a. This u of t minus a having two values 0 and 1. Therefore, when this is 0, this term becomes 0 for condition t less than a, and the second value for that displaced unit step function is 1. Therefore, 1 into f of t, we get f of t for t greater than or equals to a. Means what? In terms of figure, the portion of this graph towards left of a vanishes or becomes 0. Therefore, the graph from point C to E, point C to E represents the product of f of t into u of t minus e. Therefore, this is that graph. Okay. Then the same function I will multiply by another displaced unit step function u of t minus b. Therefore, the values for this towards left of b, it is 0. Therefore, f of t into that 0 becomes 0 for t less than b, and from b onwards up to plus infinity, the value of that function is 1. Therefore, 1 into f of t, we get f of t for condition t greater than or equals to b. Onwards, it is 1. 1 into f of t, we get f of t. Therefore, what it means in terms of figure, the portion of this f of t towards the left of b becomes 0. Therefore, this much part becomes 0. and whatever the function f of t between d to e represent the product f of t into u of t minus b. Therefore, if I want to obtain the portion between c and d, what we have to do? We have to subtract this much portion from this part, and that is nothing but f of t multiplied by u of t minus a minus u of t minus b. Means from this we have to subtract this one, and therefore from this bigger portion, if I will subtract this smaller portion, what we have? We get the portion between c and d, and therefore we get this much part. Okay, therefore from this larger part between c to e, if I will subtract this portion between d to e, we get the portion between c to d, and therefore this represents the part of function f of t between points A to B. Therefore, whenever we require to find a portion of the figure between point A to point B, then we take the help of this concept or this representation. Therefore, these are the 4 different cases I have explained for this unit step function and displaced unit step function multiplication to function f of t. Okay. Therefore, once again I will revise whatever the standard results I have discussed. So, first of all, I will write definition of u of t. Values are 0 for t less than 0 and value is 1 for t greater than or equals to 0. This is called as unit step function, and Laplace of this unit step function, your h, whatever you want you can use, it is 1 by s. This is the first result we have. Second result we have displaced unit step function u of t minus a. Again 2 values, 0 for t less than a and second value is 1 for t greater than or equals to a. We get Laplace transform of that displaced unit step function as e raised to minus as by s. This is the second result. Then some cases we have discussed Laplace transform of f of t multiplied by unit step function u of t. It is Laplace of f of t, and that Laplace of f of t is f bar of s. This is the third result. Fourth, f of t minus a into u of t minus a is e raised to minus as into
f bar of s.
This is the fourth. And one more we have seen Laplace transform of f of t into u of t minus a, as we have to rewrite this in terms of t minus, we have to convert this function f of t as phi of t minus a in terms of t minus a into u of t minus a, and as per this it is equals to e raised to minus as into Laplace of this function f of t. Here that one is f phi of t and its Laplace is phi bar of s. Therefore, four important results from this section of unit step function and displaced unit step function. Problems on this I will discuss in the third part of this video. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates or new videos. Thank you very much.